Hello children, it's Last Resort Josh here to explain to you exactly what we mean, or rather what I mean, since I'm behind the camera and whatnot, what I mean by convergent and divergent. And I can do this with a graph, like so. Let's say this is a sub n, and then this over here is n, the number of terms. Now, when you have a convergent series, as n gets greater, as the number of terms get greater, it will approach a horizontal asymptote. It will converge towards a number right here, about 0. If you have something that diverges, a series that diverges, as n gets larger, the series does not approach a horizontal asymptote, and it keeps going on and on and on to infinity. And that's why it diverges, because it doesn't go to a certain number, or horizontal asymptote. Hello children, basic comparison test time! To the miraculous graph that just appeared. So, let's say we have a function a sub n that you think is diverging. Well, to use the basic comparison test, you think of a function with a similar shape, a b sub n, that crowds it, gets really close to it. B sub n. And if the function that you choose, the b sub n, diverges, then it's reasonable to say that the a sub n diverges. Another miraculously blank graph, children. We're on convergence now, I do believe. Here's a horizontal asymptote, and here is another a sub n that suspiciously converges, or at least you have your suspicions that it converges. So, to do the basic comparison test, you're going to have to choose another b sub n that crowds it, and that you know converges. B sub n. Now, since your b sub n is larger, and it also converges, it's reasonable to say that the a sub n converges as well. Is that okay? Alright, P-series time, children. Okay, general term, right. So, we have a series 1 over n P. Now, this is just the rule for P-series, right? So this is what it looks like, and then it converges, right, when P is greater than 1. Greater than 1. So like 2 or 3 or 4. Okay, so, no. Alright. There we go. And that's a P-series. But, wait, there's more. There's also divergence. It diverges when P is less than or equal to 1. You want some examples, kids? Great! Alright, so, where'd that eraser go? Here it is. So, now let's have an example. Example 1. Oddly enough, we have 1 over n to the third. Now, does that converge, kids? Because I think it does. Because if this is P equals 3, and 3 is greater than 1, P is greater than 1, and it converges. And that's good. And example 2, you have a series 1 over n 1/2 power. And that's not good, because that's less than 1. And we all know what happens when P is less than 1, don't we, kids? It diverges. And that's P-series. Hello children. children, it's me, Last Resort Josh, here for the integral test which has magically appeared on the board. This says, the limit as b approaches infinity of the integral of a function from 1 to b that exists, then the series converges. The series for function converges. So, let's have an example, shall we? Okay. We just erase a couple things. Wait, no, that stays infinity. There we go. So, our example for right now is 1 over x. And the integral of 1 over x happens to be the natural log of the absolute value of x. Be 1. Then, plug in infinity for that, so we have natural log of infinity minus the natural log of 1, which is infinity minus 0, which is infinity, which diverges. So that means that 1 of x diverges due to the integral test. Hello children, ratio test time. Now this particular test comes in handy a lot. You can use it pretty much about every time you want to. Sometimes it's better than others, but it's pretty much the go-to test for this kind of stuff. So, let's see this. This is our little formula for it. It's the limit as n approaches infinity of the absolute value of a to the a sub n plus 1 over a to the n equals the limit. And the particular example that we're going to be doing today is the series of 1 over n factorial. And coming over here, 1 over n factorial is the a sub n, so we find a sub n plus 1, which is 1 over n plus 1 factorial. And then we find 1 over a sub n because you'll be dividing them, and it's easier just to kind of multiply them together. So 1 over a sub n is just n factorial. So then by dividing them right here, we have n factorial over n factorial times n plus 1, which equals 1 over n plus 1. So we plug that in over there, so it's the limit of n as it approaches infinity of n factorial over n factorial times n plus 1 equals the limit. Down here, it's 1 over n plus 1 equals L. This goes to infinity, and since it goes to infinity, this diverges. So, due to this, which is this diverges. This makes this. And that, children, is the end of our show. I have been Last Resort Josh, and cameraman Lucas died, and piano accompaniment Aurora and company have also died. So I think you deserve to see who's been behind the camera this whole entire time. I think I'm going to show you. Let's go. It's been me. I'm cameraman Josh, and let's go see Piano Josh. I had to take pretty quick lessons for this one. It was really weird. I had to take really quick piano lessons. I think I'm going to wrap it up for you now, though, okay?